The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Alrighty, good morning to you. Today we're going to take a look at starting chapter 8, section 8.2, and it comes in two different parts. So we'll do the first part first. Before we do that, I just want to make, let's see, two comments actually. Just a reminder that if you want to get in touch with me, you email me. I don't use Canvas and I don't look at the WebAssign messages. People keep emailing me saying, yeah, I sent you a message through WebAssign asking for an extension and you never responded, and I never will. As I mentioned when I talked to you way back when, you want to get in touch with me, email me. Okay. Secondly, I didn't mark these wrong. I went and looked at them, but just a reminder, in WebAssign, if you use a 1 as a coefficient, let's say it's supposed to be x squared, and you write 1x squared, it's going to mark it wrong. I go back and I give you credit for it, but just, you know, some of you are probably panicking going, why did I miss that? WebAssign doesn't recognize when there's an implied coefficient of a 1, don't put it there. Now, don't confuse that with, let's say I've got 1 over x plus 3. Don't just write x plus 3. That one is necessary. But if you've got like 1x squared, just write x squared. Okay, anyway, having said that, let's move forward. We're going to be looking again at section 8.2, and this is part 1. Today, we're going to talk about something called a function. Okay, function. I want to point out that function starts with fun and ends with shun. We all know what fun is, and we know what shun is too. But anyway, that probably has nothing to do with functions. Let me read to you a statement from the book. For those of you that follow along in the textbook at all, this is on page 614, and it says the following. A function is a set of ordered pairs in which to each first component there corresponds exactly one second component. The set of first components is called the domain of the function, and the set of second components is called the range of the function. All right, and we're going to talk more about that. I want to introduce the idea of people. So this is going to be people and birthdays. Okay, and I recently surveyed several people and I found out the following information. John's birthday was April 7th. Maria's birthday was August 12th. Jose's birthday was May 5th. And Sam's birthday was also August 12th. All right. Now, some things we can note here, hopefully some obvious things. Each person has exactly one birthday. People don't have more than one birthday, just counting religious experiences, of course, but each person has exactly one birthday. However, you can have two people having the same birthday. In fact, you can have a whole bunch of people having the same birthday. Okay, each person has exactly one birthday. You don't have a person with more than one birthday, and you can have several people have the same birthday. Okay, this idea of people and their birthdays works exactly like a function. For each input, that is the person, there is exactly one output. John, birthday April 7th. Maria, birthday August 12th. Jose, birthday May 5th. Sam also has a birthday on August 12th. Sam and Maria have the same birthday. Two inputs can go to the same output. but you don't have one input going to two or more outputs. That's how a function works. It may take a little while to wrap your head around it, but we're going to do that. Okay, so let's do this. We talked about domain and range. It said that the set of input values, so this is input, was called the domain, and the set of output values was called the range. Okay, so let's see, we could have input, output, x, y, first coordinate in ordered pair, second coordinate in ordered pair. How about this? Cause, effect. I always wonder, is it effect or affect? I think it's effect. Let me ask you this. So the weather is pretty hot this week. In fact, this month, maybe it seems like this century, the weather's been really hot. I need a volunteer, somebody who's willing to answer a question. Anybody? Just one person? Somebody? Please speak.
I will.
Okay, Jamie, have you been outside today?
No.
Okay. What do you think the weather's like outside?
Hot.
So would you put on a long winter coat before you went outside?
No.
No. What would you put on? Or what would you wear to go outside?
T-shirt and shorts.
Okay, all right. So did you say you'd put on a t-shirt and shorts because the weather is hot? Or did the weather become hot because you stepped outside in a t-shirt and shorts?
No, it was hot first and I put them on because of that.
Excellent. So the cause is the temperature. The effect is what you chose to wear, not the other way around. Does that make sense?
Yes.
Okay, good, good. Thank you. All right.
Mm-hmm.
Let's see here. Here we have a set of ordered pairs. And let's see, we've got 7, -1, -1, -1, -5, 3, and 8, -6. Okay. It says find the domain and the range. So what would the domain of this situation be? Let me give you a clue. It's just the x values. Oops, let me also give you a clue. Those things are hard to make. Okay, let's see here. So the domain would be, and I'm going to put them in order, -5, -1, 7, and 8. Those are the x values, the inputs, the cause, the first coordinates in the ordered pairs. So that's the domain. All right. The range is going to be, let's see, -1. Oh, wait, let's put them in order. I missed one there. -6, -1, and 3. Notice that there were 2 range values that were the same, but I didn't need to list them twice. Okay. Oh, does that work like a function? Yes. 7 goes to -1, -1 goes to -1. 2 inputs going to the same output. That's okay. So this is a function, and we have its domain and range. All right. Another example. 10, 20, 30, 20, 40, 60. In these examples, the domain is always on the left and the range is always on the right. Does this mapping describe a function? Does each input go to exactly one output? So function or not? Anybody? All right, fine. Yes, it is a function. Each input goes to exactly one output. Let's take a look at this one. let's see, 6, 8, 10, 12. How about this one? Function or not? Not a function. So no, it's not a function because we have 0 going to 10 and 0 going to 12. One input has more than one output. So it's not a function. That would be like one person having 2 birthdays. That would be nice, but that's not the way things work. All right. Questions on that? Here's another one. Function or not? We've got 3 inputs going to the same output. How about triplets? Triplets?
Yeah.
3 different people with the same birthday, okay? What you can't, so this is yes, this is a function. What you can't have is this. That's would be like one person having 3 birthdays. Maybe if they're schizophrenic or something. We're not going to go into that. But anyway, okay, so this is not a function. All right. Let's see here. How about this? Let's see, -4, -1, 0, 2, -1, 6, 0, -3, 4, 2. Function or not? Not. Because, so we'll say no, because -1 goes to 0 and -1 goes to 2. You've got one input going to more than one output, so not a function. Let's see, 1, 2, 3, 4. How about that? Is that a function? Yes. 4 different inputs can go to the same output. Okay. Here's another way to think about it. A function is predictable because for each input, there's just one output. So let's go back to this case that's not a function. If I said if x is -1, what's y? Well, you wouldn't know whether to say 0 or 2 because they'd both be correct answers. So that's not a function. But in this case, if I tell you what x is, there's only a single y value for each given x value. Okay. And we'll continue to wrestle with that for a little bit. All right, now, let's see here. We're going to look at some special notation. Let's see here. Let's say I had the equation y equals 3x minus 5, okay? And I wanted you to complete the following table values. Let's see, 3, -1, okay? So y equals 3x minus 5. When x is 3, how do we find y? We put 3 in the place of x, so we get y equals 3 times 3 minus 5, 9 minus 5, or 4. So when x is 3, y is 4, which would be an ordered pair, which would be a point on a graph, if we were going to graph this, okay? Let's find out when x is -1. So then we'd say y equals 3 times -1 minus 5, which is -3 minus 5, which is -8, which is also a point, an ordered pair, a point on a graph, all right? Now, this is using equation notation that we should be used to. Now we're going to introduce something called function notation. And instead of y, we're going to write this, which is like an italicized F and then parentheses with an X inside of it, okay? We call this F of X. It is just another name for y, but we use it when The situation we're describing is a function, meaning it behaves like a function. For each input, there's exactly one output. Now, this symbol is often confusing because, first of all, we're taught that something outside of parentheses means that you multiply. So this looks like f times x, but it isn't. It's not multiplication. Another confusing idea. Back in, let's say, Math 75, pre-algebra, or you were studying percents and you said 12 is 4% of x, okay? Of, in that context, meant multiplication. 12 is 4 times x. So if we call this f of x, it sounds like it should be multiplication. So it looks like multiplication and it sounds like multiplication, but it's neither one. It's just another fancy way of writing y. So taking this equation and writing it as a function, it would look like this. F of x equals 3x minus 5. Okay, so using that f of x symbol says this equation is and behaves like a function. For each input, for each domain value I insert, I'm going to get just one range value. Now, how do I go about finding information using function notation? Over here, we wanted to find out what y was when x was 3. In function notation, we would say f of 3 equals. So I'm putting the x value in place of the x inside of the parentheses. How do I find f of 3? The same way I did over here. That's 3 times 3 minus 5. 9 minus 5 is 4. So f of 3 equals 4. This is the function notation representation of that ordered pair. Okay? How would we find y when x is -1? We'd say, well, f of -1 equals what? 3 times -1 minus 5, -3 minus 5 is -8. So f of let's write that a little nicer. F of -1 equals -8. Let's use a different color. This is the function notation representation of the ordered pair -1, -8. How we doing? The input goes inside and the output is outside. All right, now, let's say I have the following function. F of x equals 2x minus 3. And I want to find f of 3, and I want to find f of -1. So in other words, when x is 3, what's y? When x is -1, what's y? Okay, so f of 3 would be 2 times 3 minus 3, which is 6 minus 3, or 3. So f of 3 equals 3. F of 3 equals 3. That is function notation for the ordered pair 3, 3, which on a graph would be this point right there. Okay? F of -1 is 2 times -1 minus 3, which is -2 minus 3, which is -5. So f of -1 equals -5. That is function notation for the ordered pair -1, -5. Let's see, which would be down there. My scale on my graph is not correct, so, but anyway. You get the idea? Okay, now, how about this? G of x equals x cubed minus x. Find g of 2 and g of 3. Wait a minute, what happened to f of x? Well, just like With regular variables, we don't have to just use X and Y. We can use any letter as a variable. We can also use different letters to represent functions. For instance, if this was a class in business algebra, we might have a cost function, which would be C of X equals some stuff. We might have a revenue function, R of X equals some stuff. We might have a profit function, P of X. So again, in general, we tend to use F of X, but we can have G of X or R of X or P of X or A of X, just depending on the situation. Right now, they're just getting you used to using different letters. Okay. So G of 2 is 2 cubed minus 2, which is 8 minus 2, which is 6. G of 3 is 3 cubed minus 3, which is 27 minus 3, which is 24. Okay. Any questions about that? All right. How about this one? H of X equals 3 divided by X minus 4. So we have a fraction here. We're to find H of 5 and H of negative 2. And notice how I'm saying that, H of 5, H of negative 2. So H of 5 is 3 over 5 minus 4. Again, replacing X with 5, which is 3 over 1, or just 3. So H of 5 equals 3. H of negative 2 equals 3 over negative 2 minus 4, which is 3 over negative 6, which reduces down to negative 1/2. So H of negative 2 equals negative 1/2. Any questions about that example? Okay, here's another one. H of X equals X squared plus X minus 2 all over X squared minus 5X. We're going to find H of, let's see, 5 and H of negative 2. Okay. Now, oops, sorry about that. H of 5. So we're going to have 5 squared plus 5 minus 2 over 5 squared minus 5 times 5, which is 25 plus 5 minus 2, or 30 minus 2, or 28, over 25 minus 25, which is 0. 28 divided by 0. Does anybody remember what happens when you divide by 0? It's all fun and games till someone divides by 0. Dividing by 0, we say, is undefined. Okay, you can't do it. You can't divide by 0. So what that means is that for this function, 5 is not an acceptable input. We would say 5 is not in the domain of the function. Okay, because when we put 5 in, it doesn't give us a real output. Okay, now let's find H of negative 2. That's going to be negative 2 the quantity squared plus negative 2 minus 2 over negative 2 the quantity squared minus 5 times negative 2. Negative 2 the quantity squared is 4. 4 plus negative 2 minus 2 would be what? 0. Negative 2 the quantity squared is 4. Minus 5 times negative 2 is plus 10, which is 14. What's 0 divided by a non-zero number? That is 0. That is real. So negative 2 is in the domain of the function. Okay. Dividing by 0 is undefined. 0 divided by a non-zero number equals 0. If you have 0 and you split it up 14 ways, everybody gets 0. If you have 28 and you don't split it up at all, that you can't even hang on to it. How do you do that? You can't. All right. Okay. Now, let's say g of x equals 2x. They want us to find g of w and then g of w plus 1. All right. Now, don't overthink this. Let's say I wanted to find g of 3. What would I do? I would put 3 in the place of x on the right side of the equal sign, right? So I'd get 2 times 3 equals 6. So g of w is going to be 2 times w, or just 2w. G of w plus 1 is going to be 2 times, I'm going to replace x with everything that's inside here. So x becomes w plus 1. But then further simplifying, I get 2w plus 2. How are we doing? How about this? Let's say g of x equals 4x. What would g of 3 equal? That would be 4 times 3 equals 12. What would g of star? I can't even make a star. Let's try that again. G of star equal. That would be 4 star. How about g of Barbie? That would be 4 Barbie. How about g of Ken? That would be 4 Ken. How about g of dog? That would be 4 dog. Whatever you put inside becomes the input and replaces the input on the right side. So we get 4 times that, okay? Again, don't overthink it. It's just substitution. In general, we could say g of something equals 4 times something. So whatever's here is also going to go there. All right. Now, this says let f of x equal negative 2x plus 5 for what value of x does function f have the given value. And it says f of x equals negative 7. Now, up until now, we've had a function, we've been putting in inputs and getting outputs, okay? In this situation, they're telling us the output. They're telling us that y is negative 7. So if we were to look at this in just regular equation notation, it would look something like this. Y equals negative 2x plus 5. Complete the given ordered pair, okay? How would you do that? Well, you don't know what x is, but you know what y is. So negative 7 would go in the place of y, and then you would solve for x. So what we're going to do, we're going to take negative 7 and put it in the place of y. So now we've got negative 7 equals negative 2x plus 5, okay? We're not finding f of negative 7. F of x, that whole y, is negative 7, okay? They've given us the output. This is like Jeopardy. They gave us the answer. What's the question? They gave us the output. What's the input? What do we put in to get negative 7 out? Okay, so here we're going to subtract 5 from both sides. Negative 12 equals negative 2x. We're going to divide both sides by negative 2, x equals 6. So for what value of x does function f have a given value? We'd say when x equals 6. Okay, so f of 6 is -7. All right, so there they gave us the y value. We were finding the x value. But don't make the mistake of putting that in the place of x. It's in the place of the whole f of x. Okay. That is the first part. So we're going to take a break now. We've still got an hour left, which is good because we're going to need it. So I'm going to stop the recording. And we're going to come back at 11:35.